Alrighty, so let's start with project 2 here. I think I should just be able to copy this, and we'll see how well that works. And we can write the functions for it. Make a new project. 2. All right. And that was essentially the main loop, so I'll drop that here in main. Uh, Standard string, letters guessed, string for the hidden word, int here. That's our example gallows. We got to move get word. Okay, I think the other ones are probably okay here. Let's try it. We had to get the word, right? Did I give you the way to get a hidden word? I didn't give you that, did I? Okay, so we have to go get the word from the user, making sure it's 4 characters long. Okay, so we can go, let's go add a, this doesn't have any function signatures, really? Create definition, extract function. All right, we can write it ourselves then, that's fine. So string get word. So we need a string for the word. And we can ask them, enter a word, if at least 4 characters long. And we can see in our word, and then we need to start checking, right? We'll check the length of it. So while, say, word dot size is less than 4, keep on asking again. I guess we could just start it here as like nothing, and ask them to enter a word, and not even tell them invalid, just start at something less than 4, and we're done. We should be able to return the word. Right? Should just check for me, right? Strings can tell me what size they are. Strings are pretty handy. Okay, so we should be able to get a word out. And now, has the word been guessed given the hidden word and the letters guessed? This one's a little bit trickier here. So this one's a Boolean. This is a true or false. Yes, we've guessed it or not. Has the word been guessed? Given a string for the hidden word and a string for the letters guessed. Oh, I'm sorry. I'm doing the Python formatting here with all my underscores. Probably use the for cases here. Camel casing. That's a little more. It doesn't matter. Yeah, it's I'll leave it. Otherwise, I got to do a bunch of things. Yeah, it's just a convention, and there's tools that'll automatically fix stuff for you here. It's just something you can pay attention to. All right, so I know that the word has been guessed if every letter in the hidden word has been guessed. So what I want to do is I want to loop through the hidden word, take every letter out of it, and see if it's been guessed or not. If that letter hasn't been guessed, I know right away you haven't guessed the hidden word. Right? Excuse me. So we can do for char letter in my hidden word, and then we loop again. So for the char guess in the letters guessed, if the letter, so if the letter equals the guess, then that letter was found. Right. So what we need to do is at the start of each one of these, we need to assume it hasn't been found. Right. So matches starts off as false here. And if we find a match, then I can set matches to true. If I've gone through every letter in the letters that you've guessed and I didn't find a match, so if matches is false, or you could say if not matches, right, whichever way you like here, that's probably a little more idiomatic. We can return false. Right? We didn't find a match. Yeah. Well, so this is only going to at the first letter. So I don't want to return true that the entire thing matched if just the first letter matched. So I need to check for every letter. If it didn't match, then I know it's false here because if I'm only returning at the very end, maybe just the last letter matched. So I need to make sure I've checked every time for every letter in my hidden word that I've got a chance to return false. And then if I haven't returned a false by that time, I can just assume I'm going to return true. If I get down to here, I didn't return false. Everything must have matched. And that's sort of my default case here. Excuse me. So that should check every one of my letters in the hidden word. If it's any one of the letters that I've guessed here, set match to true. You could break your loop here. Some people like a break. I don't know. You've saved 3 extra string checks or character checks. No one really is going to care, and I just don't like breaks. So yeah, it's a little faster to break here. Uh, break is slightly faster, but I dislike them that much. I just won't use it. That's okay. I'll be a little slower. All right. So has the word been guessed? Right. And has the person been hanged? Not has the person been hanged. So this again is another Boolean. Given the int number of guesses. Now this one was pretty easy here. We're just going to return my number of guesses is less than or equal to 5. So yeah, so greater than or equal to 6, right? So if it's 6 or more, you shouldn't be able to get past 6, but just in case, right? Yes, true, you've been hanged. Game over. What a lovely children's game. Um, okay, so we've got that one. Give our number of incorrect guesses. So to display the hidden word. So this one's just a void function here. It's just going to show something. So it's going to show the hidden word and the letters guessed. Letters. So it's a similar idea to our loop of did we match it here? So we're going to go through each one of these, but we're not going to return something at the end here, right? So at the end of whether or not we found a match here, I'm either going to print the letter or an underscore, like a blank. Right? So if you've guessed it, I can print it. If you haven't guessed it, I'm going to print a blank. Right? So at the end of that, so if my matches, we can see out the letter. Probably a space here. Right? It's a little easier to see if you use spaces. Right? Otherwise, wow, my curly braces are not working very well right now. We'll see out the underscore, the blank, and a space. I just keep them a little bit separated. And I don't want any end lines, right, until I get to the very end. And I've done all of them here. I've either printed the letter in a space or a blank in a space. And after I've done all of my letters in the hidden word, I'll print out my blank, right? Okay. Oh, and then we need what's that? The guess here is you get your letters guessed. Well, that's probably just a char then, right? I didn't specify, sorry. For get letters guessed, get letter guess. So we can have a char function get letter guessed, and now we need to make sure we're not repeating any of our other letters here as we go. So we probably need to be adding the guess to the letters guessed at some point here. You could, if we passed it by reference, we could modify it. If we didn't pass it by reference, then we'd have to go do another step of adding the guess to it here. Either one's okay. Should we pass it by reference to practice that? Because that's fun. You guys sound like it looks like a lot of fun, right? Very exciting. Right? If I can pass the reference to my string, I can modify it here, right? So we'll go do that because that way we don't have to change the original loop here. So to get the letter guessed, we need to ask for a letter. And if it's in the list of letters we've already guessed, tell them you already guessed it. Right? So a letter to guess. We need a string for the guess or a char for the guess, right? CN to guess. Now, if we're just using a single char, you can't even enter more than one letter. If you used a string, we should have to make sure, hey, the string size is only 1. Right? But by using a char, I don't have to do that because it can only ever hold one character anyway. So it's just a little shortcut for me. But if they type in more than one letter, my loop's going to be a little funny because CN will just read the next one without waiting for a prompt. Because like if you type in 5 letters and hit enter, right, it's going to read the first one and then it'll throw it away, read the next one, throw it away, read the next one, right? If you have repeats. So the prompting gets a little weird doing it this way. Again, at this point, hopefully we can assume people will do probably the right thing. It doesn't happen in the real world, but we're just going to assume people will do the right thing for now. All right, so we got the guess, and then we want to check if that guess is in my letters guessed already, because then I'll have to do it again. So I'll say, I don't know, bool for already guessed is false, and then for char letter in my letters guessed, if the letter is equal to the guess, my already guessed is true. And as long as this is true, I want to keep on doing this thing here, right? Kind of give them a message, I guess. So maybe we see out here, already guessed that letter. And then line. We could even tell them at the start what letters they've already guessed in case they forgot. Some people forget when they play Hangman and they're bad at it, like I am. Um, this is probably okay. So we'll spit out the message here, but then all of this then can go in a loop while already guessed is true. Yes, that's a little bit ugly, but we'll try it here. So we'll set it to true just to make my loop run because I don't like do loops while already guessed. That's a little silly here, but that's okay. And then inside my loop, I'll set it to false unless I do see a match here. That way it runs once. That's a lot of work to make it run once. Should we do a do loop? I hate do loops, but that's fine. We can do a do loop. All right, we'll do. Just so obnoxious. Boolean for already guessed. And then we say while already guessed. Guessed. Oh, I still have to declare it out here though. I don't have to set the value. I just have to declare it. Semicolon. Stupid loops. So dumb. All right, and then we can return the guess. And at some point we want to, oh, goodness. Everything has to be out here then. That's annoying. That's right. I don't even need that. Okay. Return the guess, and then we need to add that guess to the letters guess. So we'll take my letters guessed string and we'll add the guess to it before we return. Right? I want to take the string you gave me and add that guess in so I don't have to do it down here. A little weird, but sure. Again, we're writing the code. It's up to us. Okay? Then, is the letter guessed in the hidden word? This is not a very helpful comment, is it? So ideally, the function tells you what it's doing. I don't know why I put that there. I'm sorry. I'm offended. Right? So this is a true or false, right? Given a char for the guess and a string for the hidden word. Now this one's pretty quick, right? We're just going to loop through our letters in the hidden word. Let's go copy that. And if my letter is equal to the guess, we can return true. At the end of that, if we didn't return true, we're going to return false. That's just checking a single letter, right? That one's not too bad. We could actually use this in these other places where we're doing the other checks, right? If we wanted. I don't think it saves us much time, but that's okay, right? Because we're doing that same idea. Is this letter here or not? Okay, we got that one. And oh, I was missing a parenthesis there. Shoot. Okay. Number of incorrect guesses goes up by 1, and then we have to print the gallows, right? So that's another void function, print the gallows, given an int number of incorrect guesses. Now, lots of different ways to do this one here. Another semicolon, sorry. Let me go back to grab my sample gallows here. This is the full one. The lazy approach is we just have a bunch of these here, so we can say, hey, if my number of incorrect guesses is 0, we're going to see out this, right? But with no body. So we just have that, right? That one. And then we can add either at the start or the end here. Either way you wanted to do them here is fine. Right, and we just keep on adding in all of these here. But we need our end lines, that's right, plus an end line. End line plus these. There we go. And then that's the one. Now the formatting is a little awkward here, so I'm gonna like have those over so they're not in the way of my gallows. I don't know if that makes any sense or not, but it might look a little bit nicer here. Quote, 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 quote. All right, tabbing ahead doesn't work here. That's fine. Oh, it doesn't work. I forgot. Really want that to work. And then probably just an end line after that one. Oh my goodness, what did I do? Clicked on something. No, it moved it. All right, I tried getting it formatted nice. It doesn't want to. That's ugly. All right, but that's zero, right? Sure. Else if my number of incorrect guesses is one, then we add the head here. Right? Otherwise, two. You could do a bunch of if else inside of each one of these prints here. I don't know. That feels complicated to me. I don't know if this is actually easy or not, but uh, two. Then what do we have? The body, and then three. We have an arm. So we have an arm, or I forget what I put there. Yeah, two arms like that, right? Or two dashes for an arm, and then four is two more, and then five we got a foot or a leg slash, right? And then six. And the other one. Now you have to do doubles because of the backslash, right? That's the escape character. It looks a little funny, but it's not the end of the world. And really, that's it. That's all this one does here. I should print the gallows. I think, am I just missing a curly brace? Is that what I'm missing? There we go. All right. Without having to change much, I think I fixed a semicolon and a parenthesis and a curly brace. Should we try it? Think it'll go? I'll be amazed if it works the first time. Bless you. So, dog. That's not four characters long. Okay, well, that seems to be going okay so far. Well, apple. All right, what letter should we guess? E. All right, we found an E. O? No O. T? Yeah, look at that. It prints both of them. Cool. What's next? C? Uh-oh. Oh no. Um, huh. Lost a couple. Right, again, the way it does the inputs here, it just keeps on eating them. All right, what other letter? A? L. I guess maybe we want to print the word at the end here. That's kind of okay. Um, so at the end, we can see out the hidden word, and line, or say, I don't know, the word was. I mean, you just entered it, so it's not very exciting to tell you at the end, but sure, why not? Um, yeah, that's Hangman. That went okay for you? And just a way to use a bunch of functions and not use global variables and things and try and keep them all around here and just breaks it down relatively nicely. Right? Main is pretty small. It's a nice little goal there. Works out pretty well. All right, so let me go commit that before I forget. Excuse me. Oh yeah, good. Project two. All right, sweet. And should we talk about the next project? Do that one first? All right, we'll do that. So let's go. I got to get a new classroom. GitHub link for you. We're getting good at repositories now, right? Practice. We're getting there. Three plus template. All right, cool. No, shoot, not public. Hang on, I gotta get back. We have to do private repositories. That's a weird default. Should have been private. All right, cool. This will be our last individual project. Here, very exciting. Project 3, so 2 weeks from today then puts us out to the 12th at 11 a.m. And how many points was the last one? I forgot. All right, so we should do 30 for this one. All right, and I've got it stolen from over here, or reused from over here. All right, so we're going to build essentially a Ticketmaster program, but there's no website because all we have is console input, right? Eventually, you can do the website stuff, but for now, so we're going to be able to do create shows and sell tickets for shows. Sorry, my sugar's a little high right now. That is unfortunate. Give me 1 second. I didn't take insulin with my breakfast. That was smart. All right. So we're going to be able to do three different things. So this program runs in a loop with a menu. We got three options. So one is to add a show. So to add a show, they need to tell me the name of the show. And what we're going to do is we're going to make a file using that show's name. So, hey, if you want to sell tickets for the Eras Tour, we'll make a file called Eras Tour. Right? If the file already exists, tell them it already exists and go back. Right? Because we already have it. We've already sold tickets for it. We don't want to blow it away and mess anything up here. We'll ask the number of tickets available for the show. So we're not doing like particular seats. We just have um, total number of tickets. So like, hey, there's 500 tickets. Great. So now you have ticket 1 through 500. 1, 2, 3, 4, 5. Right. We're going to write that X number of blank tickets to the file with a ticket number, a blank for the name, and a 0 for a confirmation code. So we're setting up a file with 500 empty seats, essentially. So option 2 then says, okay, let's sell tickets for a show. So enter the show name. If the file doesn't exist, tell them it doesn't exist. Right? Oh, I want to sell tickets for Eras Tour. Okay, great. I found that file here. Read all the tickets into a vector. We don't want to bother with arrays. Vectors are much easier here. Ticket name, or I'm sorry, ticket number, name, confirmation code. Uh, so we can use three different vectors. It's not ideal, but we don't have a better way of doing it till next week. So next week, no, shoot, we're doing vectors for 2 weeks. We'll just do three different vectors: a vector for ticket number, a vector for name, a vector for confirmation code, and at index 7 for the ticket number, index 7 for name, and index 7 for confirmation code are all the same ticket. And you just have to read three different spaces here. It's not great, but it'll be okay. Don't worry too much about it. We'll tell the user the highest ticket number they can purchase and ask what ticket they want. Hey, we've got 500 seats. What ticket number do you want? Right. That way they're not just guessing random numbers here. And then we'll check and see if the ticket's available. Quick, easy way of doing that is seeing if the confirmation code is 0. Right? If it's not available, tell them to pick again. Oh, okay, you can't have that seat. Try another one. If it's available, ask for the name for their seat, and we're going to generate a random 6-digit confirmation code between 100,000 and 9999999. Right? And then we're going to add the name and confirmation code to the appropriate place in the vector and rewrite the file. We're not going to mess with trying to change files in the middle. There's ways to do that. It's hard right now. And files are not that large. We can just blow it away and rewrite. Right? So if I've got all my information here, if I've got 10,000 seats, I can write 10,000 lines pretty quick. It's going to go pretty quick for us here. So that's the option 2, selling tickets for a show. Then option 3 runs a report. Okay, it's showtime here. As people show up here, print the show name, display all the ticket information. I'm sorry, get the show name. What show do you want to run a report for? And display all the ticket information for the ushers to check people in. So you show up, hey, here's my name, here's my confirmation code. We'll see if you match on the list. Here, you get in. Right, that sort of thing. So um, writing a file, right? Reading and writing a file, and reading a file. Right? Lots of file practice. And we're going to use vectors to do it here because they can be X number of tickets. Right? I don't really care how many tickets are there. I'm just going to read all the tickets out. Right? Should work pretty well. That make a little bit of sense? All right, so let's do for 30 points here. Let's turn this on in online with the URL. Uh, 3. Let's just do um, option 2, and option 3. Create files. Sure, we'll just do 10 points. Option 2, sell tickets, 10 points, and option 3, run report, 10 points. 2 is obviously the most amount of work here. Right? 1 and 3 aren't okay. I'm going to change it here because now I feel bad. Go 5, 5, and 20. Because that's just writing. This is just reading, and here's reading and writing, doing all the work here. Right? We'll do it that way. All right, that's our next project. Right. So what we've done with files so far, let me go back and open up my recent list. I want to go, that's fine. We did a little bit with files, right? With is that our shopping list? Or was it the sales register? I think it was the shopping list, right? Where we said, hey, let's use a delimiter here. Because then I just will read out files, read lines until I'm done. So if you put the ticket number and a delimiter and a name and a delimiter and a confirmation code, you can just read line by line by line until you run out of lines. Works really well. Uh, that's probably a nice, easy approach for that there. So similar idea. What we didn't look at is um, we did check to make sure files opened, right? So we did. I don't think we actually checked any of these though, did we? It was in the other one. Let me go back. Or it's on GitHub. I'll just open it there. Our sales register. Oh, hey, if it opens, we know the file exists, right? That's a quick little way to check. Open the file for reading. If it opens, it exists. If it doesn't open, we didn't have, like, it doesn't exist, right? And I'll open the file. So as you're checking to see if the file exists or not, try and read it. Yeah. Well, so depending on which option we were doing, right? So for option 1, if it exists, don't make another file. Just tell them, hey, you already have a file for that, or already have that show, right? For 2, if it doesn't exist, we can't sell tickets for a show that doesn't exist. We have to prompt again for another name, right? And then for 3, again, if it doesn't exist, we can't run the report, right? Um, yeah. So this one, if it doesn't exist, is good. Then we have to go write it. This is if it doesn't exist, it's bad. Right? So it just kind of depends on our situation there, right? So we've got ways to check if files exist or not, right? Um, try and open it. It's pretty quick here for that one. I think that's all you're going to need. And then we did our vectors on this one, right? We said, hey, let's open up a vector of string here, and we'll go get the line. Again, we're using the delimiter, right? What was my target? I defined that. Oh yeah, up here I defined that as the thing I was going to look for, right? Finding a character in the string. Um, split it into the pieces that we need to, right? Or you can use input string streams, right? Rather than trying to do substrings. You got some choices, right, for how you want to handle those. So we can split it apart, right? But now we're going to read the ticket number should be an integer. The name might be blank, right? If the ticket wasn't sold, the name is blank. So we're just going to have delimiter, right? There's nothing in between them here. Um, and then the confirmation code should always be an integer, either 0 or the actual 6-digit number, right? Um, yeah, so I think that hopefully will go pretty well. We should have everything we need, put together our files and our vectors. And don't use arrays because we don't know the size until we've asked the user. So we can't even make an array of that given size. It's just not going to work well. Eventually, we'll get to how we can do that. We don't get to it this chapter, though, if I recall. There's some fun, silly things we can do in pointers, where you can make arrays of dynamic sizes using pointers because they're kind of magical. Um, so Let's look at arrays and vectors again here. So let's look at uh, multiple arrays here, because that's something we're going to do here. So we open up arrays and vectors. We'll come back here. Okay, so far this was all numbers here. So if I wanted to do something silly like let's keep track of sports players. Let's get their name and their jersey number. That's a thing, right? So we'll write a vector of type string here for names and a vector of type int for numbers or uh, jersey numbers, right? And we can either pre-size them or not, right? We don't know how many are going to be here, so we'll just ask the user, hey, enter a player's name and their jersey number or something to quit, right? So we'll get a string for some input, see out, enter a player name, a player name, quit to stop, and we can see in our input. So we're going to assume, right, while my input does not equal quit here, we can keep on going. Oh, goodness. There we go. So if it's not quit, we're going to take that name, we're going to add it to name. So names dot pushback, right, to add to the end here, we'll add the name because it wasn't quit here. I'm sorry, input. Right. Input. Right now we need to get the number. So now we've got a int for number up here, int jersey number, and then we'll ask for their number, jersey number for that name, and then we can see in the jersey number, and then we can take our jersey numbers, and we can push back that jersey number, right? And then enter player name or quit to stop, right? We'll just keep on going. So eventually we'll have a list of players that should be the exact same size as the list of jersey numbers. So the player at index 0 and the jersey number at index 0 match, right? So we're just going to use parallel indexes here, right? So then I can ask them, we can look them up, right? So let's say, see out, enter a jersey number to look up. And sure, we'll grab this one here. Now to go find the matching one, right, I need to loop through. So I can go for index is 0, index is less than, now, I don't know, jersey numbers or names, either one, they should be the same size, right? Index plus plus. So we're going to look through every single number and see if we found a match, or every item in this vector. So if my jersey numbers at the index is equal to the jersey number you just entered, then, oh, hey, that one belongs to, we'll can see out, that number belongs to, we can go back to our names at the index here, right? Because the index of my player number is the same index as the name index, right? So I can use the fact that they're parallel to go grab that player's name. And you just entered all these things. It's not very exciting, but let's give it a try, see if we can find it. And at the end, if we haven't found a match, right, we could tell them we didn't find a match. So maybe we have a Boolean for match starts off as false here, and then match equals true. And if not match, yeah, didn't find or couldn't find that jersey number, right? Just a way to give them a little message at the end in case we screwed up somehow. Right, so some player's name. Help me out here. I don't do sports. Michael Jordan. Michael Jordan. Uh, shoot. I broke it. Hang on. Why did it break? Input. Input to not quit. Add it. See in the jersey number. See in the input. Oh, because we're mixing and matching strings and ints. I think that's why. Here. Is that should have worked for us though, right? String and int. Wow. Oh, I had a space. Right, we weren't using get line. There we go. and get line given cin an input. Uh, include string. Is that it? There we go. So hopefully get line will work here. Get line. That might have been it. We'll see. We can hope. All right. Michael Jordan. There we go. Okay, jersey number. Michael Jordan. 23. Right. Another player name. Messi. EI? Just I? Okay. Oh man, we broke it again. Could have gotten. Bless you. It worked once. I got the next name. It wasn't quit. And it broke on jersey number prompt. Makes the matching input so obnoxious here. Let's see why. I think this is the problem here. So if we do a get line, Michael Jordan, and let's step over, enter, you said 23. Okay, it's got the jersey number. That's good. It's got Michael Jordan. Enter a player name. Oh, so get line, grab the enter key that was left after grabbing an integer. Because when you ask for an integer, it just grabs the number, but the enter key is actually a character there as well. So get line is going to read that. That's annoying. So let's try it twice. See if that works for us. Michael Jordan. Oh, let me take out the breakpoint here. And 23 and Messi. What number is Messi? 10? All right, another player name? Tom Brady. 123. Sure. All right, and we'll try quit. All right, so what number should we look up? 7. Couldn't find that jersey number. We didn't enter a 7. All right, now we got to do it again. Michael Jordan, 23. Messi said was 10, and Tom Brady, 123. And quit all uppercase there. Uh-oh. All right, jersey number to look up. Let's look up Messi. 10. The number belongs to Messi. I was able to look it up here. So if we keep our vectors in parallel, right, where the first indexes match and the second indexes match, or going this way, right? Match and match and match and match. We can just find the one, whichever one we're looking up here. Hey, I want your ticket number, or I want this one, or whatever it happens to be, and then find the name and find the confirmation code. Right. Again, this is not ideal. We just don't have a good way of working around this yet. So 2 more chapters, or so the classes chapter, we'll have a way to work around this here. Yeah. So you'd have to like resize it or resize it and say, hey, I want 100 spaces. We could. And then you would know there was no name if it was blank. Yeah, you could do something like that. That could work. You you're giving up using a lot of extra space to make it a little easier to use, and that's a trade-off. Like those are valid choices to make sometimes. All right. All right, so those are parallel ones. There's more. I think we're going to save so you can remove stuff from vectors and add stuff like to remove items from given locations. Let's wait till next week here. I don't think we're going to have, I don't think we'll run the whole hour 15 either of these next 2 days here. We'll spend more time practicing. It's a weird concept the first time you look at it. So spending time practicing, going through the Zybook exercises, and spreading this out is going to help. Uh, Again, the index notation's a little funky. Uh, I practice that, and I always like using the at notation with my vectors. You don't have to. You can use the same index notation with vectors as well, whichever one you prefer. It's perfectly fine. Um, excuse me. Um, yeah, I think that's probably pretty good for today. Sound okay? We can get started on the project. So we can go from there. Okay. All right. Thanks, folks.